Good morning. We will try to look at some of the aspects of natural gas. So as I mentioned to you again, it has methane mainly, some propane and butane is also there. Mainly 80 to 95% is methane. There could be a small fraction of ethane, and then all other hydrocarbons, higher hydrocarbons are less than 5%. Okay, and if you look at the sources, this is found in oil fields. These oil wells could be petroleum wells, these could be dry wells. So there are two types of wells, one is wet well, the other one is dry well. In the wet well, you have petroleum, liquid petroleum coming out, and the top part is gas. So gas and liquid both comes out of wet wells. And then there are some wells which are dry wells. That means there is no liquid petroleum, it's only the gas that comes out from there. Other than this, there are natural gas fields which are dry wells essentially, and then methane can also be extracted from coal bed. You must have seen that there are many accidents in the coal mines because of the gas. What is that gas? It's essentially methane. So that methane can also be used for making compressed natural gas if we know where it is, how much it is, and there are technologies available to convert into CNG. So there are two biggest natural gas fields, one in Iran and Urigno gas field in Russia. So these are the two countries where you have the largest reserves of natural gas, and I think this is of the order of 101 to the power 3. I think this number is not correct. This must be in several millions of cubic meters. So I think either a million is missing or something like that. So this must be like thousands of millions of cubic meters of gas is available, and then gas is produced from these oil wells. When this is produced, this is called casing head gas or associated gas. Okay, that's what is the name, and it can be stored either as a liquefied form, where you have to reduce the temperature up to -162 degrees C, or you can store it in compressed natural gas form, which is you have to increase the pressure up to 225 to 250 bar. This fuel is in large scale use world over since 1960. So that means we already have more than 55-60 years of experience on this natural gas. So it no longer is called an alternative fuel, it's more of a conventional fuel, and it's being used all over the world in different types of technology engines. More than 3.5 to 4 million vehicles are there now in the world which are operating on CNG. They are mostly used in Argentina, Brazil, Pakistan, and in India I think there are about 1 million vehicles in different cities which are running on CNG, and there is a rapid growth in the transport operations in Europe, largely because of the low emissions, and there are more than 7,500 filling stations all over the world to fill the CNG into transport sector. Now I mentioned to you that the filling pressure inside the tank is a strong function of temperature. So you can see this graph shows here, this is the pressure and this is the temperature. You can see that as the temperature increases, the pressure in the tank also increases. So you have to actually design your cylinder keeping in mind the variation in the temperature that you can experience in the daytime. If you look at the filling, during the filling process into the cylinder, the gas actually heats up, because the cylinder pipeline, it has some flow energy, and when it goes into the cylinder, that flow energy gets converted into sensible heat and it gets converted to heat. So when the cylinder is being filled, the cylinder actually gets heated. Okay. So typically, just to be on the safe side, the service pressure is kept up to 225 bar only, and it ends up with 225 bar at some elevated temperature because of the increase in temperature. Okay. In spite of being ambient being around 25, the tank temperature can go up to 40 degrees centigrade. And then as the gas is going to cool to ambient temperature with time, the pressure in the cylinder will fall to around 210 bar. Okay. So you will end up actually having lesser pressure than what you actually filled, after say 1 hour, even if you do not use any gas, and that reason is the reduction in temperature or the heat loss from the cylinder to the ambient conditions. Okay. So, if you want to prevent this such a underfill where you have filled up to 225 bar, but say after 1 hour it is only 210 bar, one of the things is that you have to fill the temperature at slowly. So, once you fill it slowly, it will give it enough time for the heat to get dissipated and the underfilling will be lesser. And or the second thing can be that you can pressurize the tank in the first place to a higher pressure. So, instead of filling it up to 225 bar, you fill it up to 240 bar, 250 bar, so that when the cylinder cools down, it comes to 225 bar, you have enough amount of gas in the cylinder. So, tanks are usually designed to be filled up to 1.25 times the service pressure. So, suppose you are designing service pressure is 250 bar. So, designing pressure has to be 315, 320 bar. Okay. That much margin you have to keep just in case of the accidental fill or there is a crack in the manufacturing, at least that much margin you have to provide while you are designing the tanks. Okay. And all the qualification testing, that means has to be done at this pressure. Qualification testing means that once you have a cylinder needs to be periodically tested. It's not that you just buy a cylinder one time and you can use it forever. It has to be tested. So, what is done is that the cylinder is taken and then hydraulic testing is done. And in India, the institute which does is there is a National Explosive Institute in Nagpur. Okay. They do this testing, and every cylinder, not only for CNG but also for other gases, has to be tested once in 3 years. If you do not test it, it is illegal. If there is an accident, you will be held liable to it. So, basically you take the cylinder and you take it to a authorized agency where the testing is done, which is certified by them for the infrastructure and for the testing protocols. And then that agency or the institute itself, what they do is they increase the pressure up to the desired pressure. They put it in a hydraulic tank and increase the pressure. And when say this is to be tested at 300 bar, so they will pressurize it up to 300 bar. If the cylinder fails, so it will implode. Okay. And it is done such that even if it implodes, it does not cause any accident. Okay. So, that is how the type testing is done for the cylinders, and every cylinder has to be tested once in 3 years. So, if you look at the fuel tank technologies, there are 4 basic types of fuel tanks used for CNG applications. So, design which one we are going to use, it depends on the weight, how much weight we have to reduce and how much money we can pay. Obviously, if you want to have a stronger cylinder which is lighter, you have to pay more. If you can, and you have to go, because you have to go for more newer, stronger materials such as carbon fiber. Okay. But if you can't afford to pay more, then you go for cheaper materials such as steel, mild steel. Okay. So, all designs have equivalent safety because they have to meet the same safety standards, and designs type can also determine how a tank may be handled or how it may be filled. For example, if you look at the tanks, there are 4 designs. So, first design is all metal tank. So, all metal tank can be aluminum or steel. If it is steel, it is the cheapest. If it is aluminum, it is slightly lighter than steel, but it is going to be more expensive. But anyway, both of them are the cheapest among the all 4 designs. The second is the metal liner reinforced by composite wraps. So, you have a metal liner. Now, the metal liner, the function of the metal liner is inside and then it is wrapped with carbon fiber. Okay. So, carbon fiber is what provides it strength. Okay. The metal liner is the thing which does not allow the penetration of methane, because methane molecule is also very small. It should not penetrate through the matrix. So, if you just have carbon fiber, it is possible that methane molecules may actually penetrate through carbon fiber, but they do not penetrate, certainly do not penetrate through metal. So, metal liner reinforced by composite around middle. So, this liner takes around 50% of the pressure and composite takes another 50% of the stress. caused by internal pressurization. These are less heavy, but they are going to cost more. Why? Because the glass fiber or carbon fiber is more expensive than metal. So, third design is that the metal liner reinforced by composite wrap around entire tank. So, in the second design, the wrapping is only from here to here, not at the end. In the third design, same design, but wrapping is all over the place. So, you can see even the ends you have the carbon fiber wrapped around, and if you cut the section, cut the cylinder, you can very clearly see the design here. The carbon fiber is all outside and the metal liner is inside. 50% of the load is taken by this. Liner takes small amount of the stress in this case. So, in the third design, liner will be even thinner and the carbon fiber will be even thicker. So, less than 50% is taken by the liner, more than 50% is taken by the fiber. Okay. So, obviously, they are going to be lighter now because much of the metal is now replaced with carbon fiber. So, they will be lighter and they will be more expensive, and here you see it is end to end. So, carbon fiber is actually continuous, it is not just at the middle section, it is continuous. So, this is the third tank design. And the fourth tank design is that you have plastic gas tight liner reinforced by composite wraps around the full tank. Entire strength is composite reinforcement. So, now the liner is so thin that it does not really provide any strength. Entire strength of the pressurization is taken by fiber, and this could be composite. That means in one, from outside it will look like one compartment, but inside there may be two. Okay. So, these kind of designs are also possible. So, entire strength of the tank is composite reinforcement. These are lightweight, but they are most expensive. Okay. So, these are the 4 different designs of the tanks that are normally used in transport sector in the country. Okay. But ask me which are the ones that we use in India? The first one, and among the first one, which ones? The steel ones. So, we are using in the transport sector, we are using very cheap cylinders. Now, what happens is when you use such cheap liners, you are actually carrying lot of weight. I mean, if you look at the cylinder itself will carry around 4 or 5 kilograms of gas, but the cylinder itself will weigh 40 kilograms, 45 kilograms. So, the total weight of the cylinder will be 50 kilograms just for the cylinder itself, including the gas, and it will carry only 5 kilograms of gas. Now, if you are in a car, instead of having a heavy cylinder, you can put one more passenger, at least half passenger, or maybe 2 extra suitcases, that will give you more money, right. So, in transport sector, it is very important to have lighter cylinders, because you are, if it is stationary applications, I do not mind, it is sitting, whether it is 50 kilo or 10 kilo, it does not matter. But in a transport application where you have to carry the cylinder itself along with it, it basically reduces your load carrying capacity, right. So, if you look at the CNG performance, the octane rating of the CNG is higher than gasoline and in dedicated CNG vehicles. So, in a dedicated CNG vehicle, power, acceleration, cruise speed can be greater than gasoline powered vehicles, but this is dedicated vehicle. If you are using a transition vehicle, okay, transition vehicle means it is a gasoline vehicle or diesel vehicle which you have converted into gasoline by reducing the compression ratio and other things that I discussed yesterday. Okay. So, if that is the case, in that case the power, acceleration and cruise speed will be lower, but if it is a dedicated vehicle which is designed for CNG, the speed, cruise speed, acceleration, power can be higher than the conventional vehicles. Reason is that you can, since it is a higher octane number, you can take the advantage of increasing the compression ratio. So, you can afford to have higher compression ratio. So, that will give you more power, more acceleration, more fuel economy, more cruise speed. Okay. So, if it is a dedicated vehicle, you can take the advantage of the properties of the CNG. If it is a gasoline vehicle that you are converting, obviously you can decrease the compression ratio, but you cannot increase the compression ratio. If you are decreasing the compression ratio just like we did in diesel engine, there also it is a problem, because the combustion chamber optimization etc. cannot be done, because it is just a jugaad technology that is being used. Okay. Nobody bothers about all those combustion optimization. So, they are sub-performing vehicles actually. Transition vehicles are sub-performing vehicles, they are not optimally performing vehicles. So, in addition, due to the cleaner burning characteristics of the natural gas, CNG engines can run more efficiently than gasoline powered vehicles. CNG engines are also generally less noisy. Why less noisy? Because the higher octane number. than diesel engines. So, diesel engine, gasoline engine, they are compared to them, they are less noisy, and they have clean burning characteristics. Clean burning characteristics because gasoline and diesel both are liquid fuels. Their mixing with the air is not that homogeneous. CNG is a gas, it can mix more homogeneously. If it mixes more homogeneously, obviously the combustion will also be better, and carbon monoxide and hydrocarbon emissions will be lower, and it is a single carbon fuel. So, there will be very small quantity of particulate matter formation. Okay. Now, let us look at the safety issues. CNG is a very safe fuel because it is very narrow flammability limit. When we discussed initially in the beginning, what was the flammability range? 5 volume percent to 15 volume percent. Compare this with methane. Methane is with hydrogen. Hydrogen is 4 volume percent to 75 volume percent. So, compared to that, it is much more safer, and it can be used without any problems of safety in the engines, and already we have 55 years of experience on it. So, it is a child's play to use it. It is completely non-toxic. Of course, if this room is filled with methane and it displaces all the air, one will die, but that is, it's not because of methane. Any gas, if you fill it with any gas and displace all the air, you will die. So, but it does not have additional toxicity. That means, if you inhale methane vapors, nothing is going to happen to you. Okay, so only short term effects may be there. Okay. CNG, as I mentioned, is lighter than air, so it disperses very rapidly, and minimum ignition risk relative to gasoline. So, accidental ignitions are also very less. However, leaks inside the room, indoors, can form flammable mixture because the gas is trapped, it is not allowed to escape, and it can really create a problem if it is in the vicinity of any ignition source. And once you are in the flammability range and there is an ignition source, obviously nothing can prevent an accident. Okay. So, but that is true for any other fuel as well. If you look at the emissions, there is huge reduction in the carbon monoxide emissions of the order of 90 to 97%, and carbon dioxide emissions by 25%. 25% why? Because of the higher hydrogen to carbon ratio. Okay. There is reduction in the nitrogen oxide emissions also of the order of 35 to 60%, and there is potential reduction in non-methane hydrocarbon emissions up to 75 to 50 to 75%. Methane emissions on the other hand will increase, will be higher. Non-methane emissions will be, non-methane hydrocarbon emissions will be lower, methane hydrocarbon emissions will be higher, because if the fuel leaks or if the fuel does not burn, the fuel which remains trapped in the Kreyweis volumes, if it goes without burning, obviously it will lead to methane emissions. So, the methane hydrocarbon emissions will increase, but non-methane hydrocarbon emissions will be definitely lower. Okay. Fewer toxic and carcinogenic pollutants are emitted because it does not form PAHs, nitro PAHs, very small formation takes place, and the very little particulate matter is produced. So, you can see, as far as the emissions are concerned, most of the emissions, in fact almost all emissions are lower from methane fueled engines or compressed natural gas fueled engine. Okay. If you look at the maintenance issues, proper training is required for all maintenance persons working on CNG vehicles. Why? Because you are now not dealing with a fuel which is stored under atmospheric pressure, you are dealing with a fuel which is stored at a extremely high pressure, and the guy who is handling the maintenance issues, he should be aware that it is a pressurized fuel and it should not be allowed to leak under any conditions. He should know exactly where the pressurized gas connections are there and what are the safety protocols that have to be taken. The oil in a CNG vehicle does not need to be changed more frequently. Why? Because CNG vehicle combustion is more clean, there is hardly any particulate matter. So, along with the blow by, there is no particulate matter getting mixed with the oil. So, the oil will maintain its color, it will not be soiled by soot, and therefore, you do not need to change it very frequently. Its additives will be protected for a longer time. So, CNG burns more cleanly than gasoline, and they produce less deposits in the oil, less carbon or particulate matter will go into the lubricating oil. So, that is one of the major plus points of using CNG, and also you have to understand that even the life of the engine in this case will be higher than diesel and gasoline vehicle, because the fuel itself is in gaseous form. So, when the fuel is inducted in liquid injection engines, when we inject the fuel goes and hits fuel droplets, hit the liner, and on the liner you have a very thin oil layer. That oil layer gets diluted because of the mixing with the fuel droplets, and that fuel goes into the combustion, into the crankcase most of the time. And when it goes into the crankcase, it reduces the viscosity of the lubricating oil. Also, once the lubricating oil layer is washed, there is a possibility of metal to metal contact between piston ring and the liner. No such possibility exists in this case. So, you have a lubricating oil, it will be, even if the methane interacts with it, it is not going to affect its viscosity. So, you are okay. So, the additional wear will be very less in this case. So, life of the methane engine, compressed natural gas engine, will definitely be more than a gasoline engine or diesel engine. Okay. There is no soot formation. So, when in diesel engine or gasoline engine, when the soot formation takes place, even the soot particles, they come in between the mating parts, and we saw that if the particle size is larger than the oil film thickness, the soot is going to remove the material from either the ring or the liner, 3-body wear mechanism, and it will lead to wear. No such possibility exists here, because soot formation is not there in the first place. Okay. So, these are some of the immediate benefits that are offered by compressed natural gas fueled engines. Now, let us talk about, so far we are talking about methane engines in compressed natural gas form. Let us talk about the LNG. So, now we are talking about natural gas engines, but the natural gas is stored in liquid form. So, how does it behave? So, liquefied natural gas or LNG is a natural gas that has been processed to remove helium or other impurities such as water and heavier hydrocarbons, and then condensed into liquid at almost atmospheric pressure by cooling it to minus 163 degrees centigrade. So, when you cool it, everything else will freeze and separate at other temperatures, because they will have different boiling points. So, water will freeze, and then hydrocarbons will freeze, helium will freeze, and what is left is finally methane, which will basically get liquefied at minus 163 degrees C. Okay. And that is what is going to be used in the engine. So, LNG is about 1/614th the volume of the natural gas at standard temperature and pressure. That means 1 liter of liquefied natural gas will be occupying almost 0.6 meter cube of space. So, it is a lot of densification of the energy that takes place because of the liquefaction. So, it is much more cost efficient to transport, and I think the best part is the atmospheric pressure. So, LNG does not need to be maintained in pressurized tanks. It is okay to maintain it in non-pressurized tanks, especially if you can maintain the temperature. So, the LNG tanks are non-pressurized tanks, but they are highly insulated because they have to maintain extremely low pressures, and this is one of the most cost efficient way of transporting fuel from one place to another place. In fact, now we have tankers which bring liquefied natural gas from Iran to India. Where? To a port called Dahej in Gujarat, which is a LNG port. Okay. This LNG comes there, and where it is used? It is basically used in most of the industries for industrial purposes. Right now in India, we do not have LNG fueled buses or cars. LNG distribution network does not exist as of now. You cannot go and buy LNG on a gas station right now. Okay. But maybe in times to come, we may have, if we have lot of supply of LNG. So, how do you produce LNG? By liquefaction. So, here you see these are the components of the LNG liquefaction plant. You have gas separation, metering, and acid gas removal when the gas comes, and then you have dehydration, and then you have removal of natural gas liquids. Natural gas liquids means C2 you will remove, C3, C4 you will remove, higher hydrocarbons you will remove. Once all of that comes, methane goes this side and other things goes to this side, and here you have fractionation So, in fractionation you will remove C3 and C4 as LPG and other things will go to petrol or diesel or whatever fractions. So, they will get converted to marketable natural gas liquids and the natural gas will actually come out, it will go to liquefaction. Liquefaction means here you are going to reduce the temperature by using cryogenic technology, okay, because such temperatures, such low temperatures of minus 163 is not possible by refrigeration cycles, ordinary refrigeration, vapor compression cycles. We have to use liquefaction technology such as cryogenic technology. And then the gas, natural gas, pure natural gas is converted to liquid and then you have LPG storage tanks, LNG storage tanks and then you have LNG loading through a carrier ships. You will see if you just Google LNG ships or LNG storage tanks, what will be your top priority? Your top priority is that you will look for a design which is having minimum surface area for the maximum volume. For a given volume, it should have minimum surface area. So, can you tell me a geometry which gives you minimum surface area for a given volume? Is spherical. A sphere has the minimum surface area for a given volume. So, you will see that all the LNG tanks are always spherical in nature. Okay. And if you look at the LNG storage tanks, tankers also, when I am saying tankers means carrier ships, you will also see a spherical shape there. So, LNG is always stored in spherical tanks, so that you have, especially for transport. Of course, when you are using the vehicle, spherical is a very bad idea because it is going to occupy a waste lot of space. So, in the vehicles the tanks are normal shape, you have to look at other constraints also, but as far as transportation is concerned, transportation by ship is concerned, you go for spherical tanks. If it is stored in the industries also, then also you go for spherical tanks. Okay. So, the primary processes are that a raw feed supply arriving from a gas producing field must be clean and dry. So, you have to remove the water before liquefaction can take place. It is scrubbed of entrained hydrocarbon liquids and dirt, and then it is treated to remove the H2S. H2S is a highly corrosive gas. You would like to get rid of it. You do not want H2S to enter your process plant, and also you want to remove the carbon dioxide, and then gas is cooled and water, whatever moisture traces are left, they are allowed to condense. Then it is further dehydrated and even the small amounts of water is removed. Why? Because this water, if there is any moisture trapped, it will go and it will choke the pipes from inside. The ice formation will take place and their diameter will become smaller and smaller. Finally, they may choke. So, you would not like to have even the traces of moistures. If mercury is present, then it is also removed at this stage. Then the gas is filtered to ensure that only methane and traces of other hydrocarbons are present, and then liquefaction takes place. Liquefaction takes place through cooling of the gas using heat exchangers. In these vessels, gas circulates through aluminum tubes exposed to compressed hydrogen nitrogen refrigerant. So, hydrogen nitrogen mixture is used for as a refrigerant. Heat transfer is accomplished as the refrigerant vaporizes. So, when it vaporizes, it will take away the heat and it will cool. So, cooling in the natural gas in the tubes before it returns to the compressor. The liquefied natural gas is pumped to an insulated storage tank which is spherical in nature, where it remains until it can be loaded onto the tanker. Okay. So, this is the technology for liquefaction. Okay. Now, if you look at some of the other facts to get a feel of how it is compared to conventional fuels, yeah, question? LNG offers energy density which is comparable to gasoline and diesel. So, on a liquid form, is it cold? Can you just switch off the air? So, LNG offers the same energy density as gasoline and diesel, almost gasoline and diesel is around 40 megajoule or 36 to 40 megajoule per liter. On a kilogram basis, it is 41 to 44 megajoule per kg. So, on a volumetric basis, it gives you almost the same density, not volumetric, mass basis. But its high cost of production and need of cryogenic temperatures to store, it has prevented its widespread use. So, cryogenic technology is one of the major bottlenecks. natural gas fed into LNG plants is treated to remove water, hydrogen sulfide, carbon dioxide and other components, and which freeze at low temperature. So, I told you these are the things that need to be removed in the processing. Storage. So, once the liquefaction takes place, LNG is stored in above ground tanks. So, it is not underground tanks, it is above ground tanks, mainly of double walled. So, they are double walled, because double walls provide you very high degree of insulation. Okay. High nickel steel construction with extremely efficient insulation between the walls. Okay. Large tanks are low aspect ratio, height to width and cylindrical in design with domed roof. So, it could be spherical. If they are cylindrical in design, they should have low aspect ratio, height to width and domed roof. Storage pressure is very low, actually it is less than atmospheric pressure, it is at 5 psi, which is 1/3 of a bar. Okay. So, very low storage pressure is required. So, LNG tank one of the construction can be of this type. So, you can see that it has a domed roof. Domed roof is basically to reduce the heat transfer. Okay. And then you see this tank, the beauty here is this tank is not connected to the ground, because if it is ground, lot of heat will be gained from the ground. So, it is actually on some kind of pillars. Okay. And then there is a double walled construction all over the place. Okay. And there is a very efficient insulation in between them. So, this is how the LNG storage tanks are made. So, this is just the entire gamut of the pipeline system. So, you see you have crude oil or natural gas from different wells on the land. So, these are not offshore, these are onshore wells, and then there could be crude oil or liquefied natural gas offloaded from overseas tankers. Okay. And then it goes to natural gas and crude oil from offshore drilling platforms. So, basically there will be 3 sources. One is the onshore facilities, offshore facilities and imported ones. Okay. So, from all these it will go to storage and treatment facilities. Okay. And then it is pumped, and all this will have both liquid and natural gas transmission lines. This will have natural gas processing facility, oil refinery and chemical plant, such as the one that is in Mathura and Jamnagar in Reliance refinery. Okay. And then from there all the different fractions will be separated: natural gas, LPG, gasoline, diesel, etc., and then they will come to storage facility. Okay. You must have seen these storage facilities. There are such kind of storage facilities in all cities of the country. In every city of the country close to the railway station, there is a place where you will see large storage facility of the hydrocarbons. That is basically for the distribution of the hydrocarbon, different types of hydrocarbon in that localized region, right. There is one in Kanpur as well, close to the railway station. Okay. And then from there, the natural gas or hydrocarbons, they will have pumping station, and then from there it will be distributed to different applications. So, it could be going to industrial users, it could be CNG or LNG, could be going to commercial users, it could be going to residential users, or it could be going for transport use. In India, this is mostly natural gas in compressed form. So, this pipeline that takes the fuel, natural gas, it does not take the natural gas at compressed, it is still not compressed natural gas, because it is not 225 bar, it is the pressure is still much lower. Because if you want to put a pipeline carrying the gas long distance with very high pressure, the cost is going to be very high. So, what is done is normally this pipeline is at a low pressure. Okay. For example, in IIT Kanpur, there is your hostels are connected with one such pipeline. It is called PNG. PNG is piped natural gas. Okay. That is a part of such a distribution network. So, that PNG carries the gas at 1 bar pressure. it is connected to your kitchen in the hostel, and there all the cooking takes place. My house is connected with PNG. Okay. So, I am a residential user, you are more like a commercial user, okay, large scale cooking, all right. So, small quantities up to 70,000 gallons, gallon is 4 liter or less, are stored in horizontal and vertical vacuum jacketed pressure vessels. These tanks may be pressurized anywhere from 5 psi to 250 psi, that means 1/3 of a bar to about 20 bar, 15-20 bar. LNG must be maintained very cold, minus 163 degrees C or lesser, to remain in liquid independent of the pressure. Okay. So, if you look at the LNG vehicles, although we do not use them in India, but there are some countries where LNG is used for transport purposes. So, you have LNG vehicles, and obviously from the LNG vehicles heat transfer into the tanks is a big problem. So, there also the LNG tanks are extremely insulated, but nevertheless let us talk about the performance of such vehicles. So, if you look at the performance of the vehicle, there is no difference in LNG vehicle performance, operation and utility when compared to diesel, as good as diesel. Okay. The high ignition quality of LNG is similar to diesel, providing similar durability and engine life, overall engine life. Okay. Safety, LNG vehicle parked indoor and unmoved for a week or more, what will happen? You have a car in the garage and it is filled with LNG tank, you leave it for 1 week, whatever best insulation you may have, heat transfer will take place, and once the heat transfer takes place, what will happen? The gas will vaporize, and if the gas vaporizes, the pressure will start building up. So, there is always, in such a situation, there is always a safety valve. So, once the pressure goes above a safety limit, then safety valve will open and it will vent the natural gas into the garage, and the garage will be then full of natural gas and it may cause an accident. So, if it is parked or unmoved for a week, it will vent a flammable gas mixture that could catch fire in the vicinity of an ignition source. So, this is one of the problems with the LNG, or even liquid hydrogen vehicles have the same problem, because they also have very low temperature, has to be maintained in order to maintain it in liquid form. Refueling vehicle, or if you do not allow the gas to be vented, then what will happen? The pressure will keep building up, tank will explode, okay, tank will fail. Okay. So, refueling vehicles with LNG require training, because fuel is extremely low temperature, minus 163 degrees C. So, if by accident you are filling the tank and half a liter falls on your hand, then what will happen? It will be like a cookie, break, you will have frostbite, you may actually have to ampute the hand, because it may be so badly damaged because of the low temperature that you may have to ampute it. So, that is why you need trained manpower to handle liquid fuels which are extremely cold, liquid hydrogen as well as liquid natural gas, liquefied natural gas, both are extremely dangerous. You should not be handled, it will cause frostbite if the skin contacts it, and also it may be a problem if large quantity has fallen in on your skin. If you look at the emissions of the LNG vehicles, they produce about half of the particulate matter compared to diesel. So, PM emissions are very low, gas can significantly reduce carbon monoxide emissions, ultimately it is methane. So, same benefits you will get, reduction in NOx emissions, volatile organic emissions by 50% or more, potential reduction in carbon dioxide emissions by 25% depending on the source of the natural gas, drastic reduction in toxic and carcinogenic pollutants. So, basically you will get the same benefits as compressed natural gas with the liquefied natural gas, ultimately it is the same chemical. Maintenance issues, LNG burns cleaner and it has longer engine life and reduced maintenance cost. Use of the LNG eliminates periodic tank inspections, because tank inspections are required only when it is a pressurized tank. If it is not a pressurized tank, you do not have to go and test your tank every 3 years or so. Fuel, because of the fuels below freezing temperatures, only trained persons should maintain the LNG vehicle. CNG also has to be maintained by trained people. and LNG tanks, more trained people, okay, because this can be really dangerous. Okay. Exhaust emissions, CNG emissions are compared with comparable with diesel in B20. THC, NOx and PM emissions are significantly lower than diesel, large reductions, no significant reduction in CO. So, these are some of the results, again these results, numbers that I showed you are not really very important, because they vary from engine to engine, vehicle to vehicle, and how you have conducted tests, it varies, but the point is that whether it is increasing or decreasing, that matters. By how much, it can change. For example, there are 3 vehicles that are compared here, one is running, yellow one is running on diesel, blue one is B20, 20% biodiesel and 80% diesel, and white one is CNG. So, you can see total hydrocarbon emissions are highest in diesel. When you use biodiesel, this reduces, and when you use CNG, this also reduces. Similarly, if you look at the carbon monoxide emissions, these are also very low. Okay. And if you look at the NOx emissions, diesel and biodiesel both have comparable NOx emissions, but what about the CNG? Negligible. Okay. Particulate matter, both have comparable particulate matter. Can you see the bar for CNG? No, it is not visible. That means what? No particulate matter. So, if you look at this table, it actually shows you that CNG is definitely a superior fuel to diesel, and it is also much superior fuel to compared to biodiesel blends. Okay. Now, I mentioned to you that there are 2 types of emissions that we bother about. One is what is regulated emission, the other one is unregulated emissions. So, if you look at the unregulated emissions, these are also important. Unregulated emissions, you have carbonyl emissions. So, among the carbonyl emissions, you have formaldehyde. So, formaldehyde is the most abundant emission compared to other carbonyl compounds in the exhaust emissions of CNG. Formaldehyde is HCHO, and methane, LNG or CNG is CH4. So, CH4 to HCHO conversion is something that happens very quickly inside the engine. Okay. So, this is the most abundant, the other chemicals are not so much present. CNG emits 95% formaldehyde with respect to diesel. Formaldehyde is HCHO. So, even though formaldehyde comes out, but is still compared to diesel, it is much lower. Okay. The other emissions are just not present. Diesel, other emissions are also coming. If you look at the PAHs and nitro PAHs, PAHs are what? Polycyclic aromatic hydrocarbons. You have these benzene rings. If you combine 2 benzene rings or 3 benzene rings or 4 benzene rings, this is called PAH, polycyclic aromatic hydrocarbons. The formation in diesel engine for the PAH takes place because diesel itself has aromatic rings. It contains aromatic content. Okay. In methane, there is no aromatic content. So, since there is no aromatic content, how will you form polycyclic aromatic hydrocarbon? By cyclization of the methane. That is very difficult, the time is not enough. So, if you look at this CNG vehicle, use of the CNG results in significant reduction in the emissions of the PAHs. At least 88 to 90%, 98% is observed in PAH associated with PM and vapor phase. PAH can be present in solid phase, it can be a part of the particulate matter. PAH can also be present in vapor form. So, both are reduced by this extent. Solid phase pH reduces by 98%, vapor phase reduces by 88% because of the use of CNG compared to diesel. So, you can see even the non-regulated emissions from natural gas will be much lower compared to diesel. This just shows PAHs associated with the particulate matter. Okay. Again, 3 fuels are compared: diesel, biodiesel and CNG, and these are the concentrations in nanograms per kilowatt hour, and these are the different PAHs, benzo, anthracene. I do not want to read the names, these are very complicated chemical names, but there are 18 different PAHs that have been identified to be carcinogenic to the human health, and they are present in diesel and biodiesel. you can see diesel is higher, biodiesel is slightly lower, but if you look at the white bars, for all these white bars are hardly visible. What does it mean? It means that there is hardly any pH formation or pH emission coming out of natural gas fueled engine. And when I am saying natural gas in both forms, liquid form as well as compressed form. Okay. Similarly, pH is associated with vapor form. So, this is the vapor form, same pH is here also. You see bars are visible, but they are still negligible. Okay. In some cases you can see some bars, again nanogram per kilowatt hour. Compared to this, these are 10 times bigger scale, this is 10 times smaller scale. So, that may be the reason why some bars are visible. Okay. But these are completely negligible, you can ignore them, it is very safe comparatively. Carbonyl compounds, there are many carbonyl compounds that are emitted. Again here this is in milligrams per kilowatt hour, again for these 3 fuels. And also you can see here the carbonyl compound emission is also very low. The only bar that is visible is formaldehyde, and this formaldehyde is also 95% lower than diesel or biodiesel. Okay. Rest of the things are negligible. Okay. So, this is as far as the toxicity, regulated, unregulated emission from natural gas fueled engines are concerned. Now, let me talk to you about how do you store and dispense the fuel, natural gas fuel. Okay. There are two types of CNG fueling stations, one is the slow fill, the other one is fast fill. So, slow fill dispensing station is basically, you imagine that you are a taxi operator. Okay. And you have 20 taxis in your home. Okay. So, would you like every time to go to the filling station, wait there for half an hour, fill your taxi and do it, or would you just install something cheap in your own facility which will run for a very long period, but it will fill the gas in your vehicle and you pay at the end of the month, which will be preferable? Obviously, the second one. So, slow fill system is a small capacity system which people can have. I mean, even if you are a homeowner and you have 3 cars, you can take the same. What you do is you put the tank, you connect to the system in the night, and this slow compressor will keep on working the whole night, and by the time you come in the morning, your cylinder is filled, and then you can go next day, work for the whole day, again come back, connect. That saves you a lot of time, and then you have to pay only one time in the month. Okay. So, in slow fill systems, several vehicles are connected to the output of a compressor at one time. So, if you have 10 cars, you can connect all 10 cars at the same time. Of course, the filling period will be very long. These vehicles are then refilled over several hours of compressor operation. It is a small compressor. So, it will take a long time to fill. Slow fill is considered practical only for vehicles of single fleet. Single fleet means single owner, single guy who is going to pay. If it belongs to all of you, why should I pay for it? Simple as that. So, that is why it is called, since the compressor is small and it fills slowly, that is why it is called slow fill system. But if you have just one car of your own and you do not want to invest in such a system, you would go for fast fill system. Fast fill system means there is a gas station just like petrol pump, you go in there and you do not want to wait there for 2 hours to gas to fill. You want something, you put the tap in and then fill it in 1 minute and then go. So, in fast filling systems, enough CNG is stored so that several vehicles can be refueled one after the other, only one at a time, okay? Just like fueling from a single gasoline dispenser. So, it is almost like petrol pump situation, and this is more like single fleet system.